morning children. Now we'll discuss some questions related to organic chemistry, and we'll discuss some named reactions related to organic chemistry. Now first one, let me take one question here in this way here. So first question is, if a question is given in this way here, which one of the following compound can be prepared by Wurtz reaction. So Wurtz reaction is a named reaction, it's a famous named reaction. So if a question is given like this here, which one of the following compound can be prepared by Wurtz reaction? So if the options are given like this, so 4 options, the options are given like this: methane CH4, and 3 carbon compound CH3, CH2, CH3, propane, and if it is given CH3 4 carbon compound CH3, CH2, CH butane and butane, and one more if it is a bond line structure branched compound, if it is given in this way here, a branched compound here. So what will be the correct answer means, to pick the correct answer first we should know what are the conditions in Wurtz reaction. So let us see the condition in Wurtz reaction, and let us see the mechanism part of the Wurtz reaction here. Now in Wurtz reaction, the mechanism of this Wurtz reaction is, so Wurtz reaction is having 2 mechanisms, that is ion mechanism and a free radical mechanism is there. Free radical mechanism and ion mechanism is there. So Wurtz reaction, so what actually Wurtz reaction is here? Wurtz reaction is alkyl halides on reaction with the sodium metal. 2 moles of alkyl halides will be taken here. Alkyl halides on reaction with sodium metal in presence of dry ether. The solvent what we are using is here in presence of dry ether. So they will be producing here higher alkanes plus NaX. Higher alkanes will get here. So this is the Wurtz reaction here, the general Wurtz reaction. Now in this Wurtz reaction here, the mechanism is through ion mechanism. It will be through, maybe it will be through ion mechanism, or it is through free radical mechanism. But in these cases, both will be through substitution mechanism here. Now, what are the conditions for Wurtz reaction? So now let us take what are the conditions for Wurtz reaction. So in that here, first condition is, in Wurtz reaction we can prepare even number of carbon containing alkanes. We can readily prepare these compounds, and or we can prepare here. Tertiary alkyl halides cannot be used for the preparation of carbon compounds, organic compounds, alkanes by Wurtz reaction. And the third one is here symmetrical. The third condition is symmetrical and even number of carbon containing organic compounds can be easily prepared by Wurtz reaction in pure form. So why can't we take tertiary alkyl halides? What will be the reason for this one means here? Tertiary alkyl halides, 3 degree alkyl halides, tertiary alkyl halides can readily form more stable 3 degree carbocation. As they are able to form more stable 3 degree carbocation, this 3 degree carbocation readily it undergoes elimination rather than substitution, and the elimination product of this result in the formation of alkene. You will be getting alkene. So instead of getting higher alkane, what you are getting is alkene. So we are getting an elimination product rather than substitution product. So that's why we should not take here tertiary alkyl halides. So what type of alkyl halides we can take means here, except tertiary, primary and secondary alkyl halides we can take here. Now suppose then even number of carbon containing compounds. Why you have to take only even number of carbon containing compounds only? Why they are prepared means here, suppose let us take a different alkyl halide. Suppose let us take alkyl halide Rx plus 2Na and R dash X. Let us take alkyl halides in this way. So I have taken alkyl halides in this way. 2 different alkyl halides I have taken. One is Rx and the other one is here R dash X. So in Wurtz reaction, when you are taking the solvent, that is dry ether, when you are taking the solvent, so what is happening is here higher alkanes. So this may undergo double to form R and R dash R it will form. This may form here R dash, or these two can combine here to form here R dash. So we are getting a mixture of three different compounds we are getting here. So you are getting higher alkanes which are three different. So we are not at all getting any one compound in pure form, and we very well know that our alkanes cannot be separated. We cannot isolate a mixture of these alkanes because these alkanes are having almost same boiling point. Boiling point variation is not much in case of alkanes. As a result, we cannot easily separate a mixture of these alkanes. That's why it is not preferable to take mixed alkyl halides or two different alkyl halides when you are going to do Wurtz reaction. Then what type of alkyl halides you have to take means symmetrical same alkyl halides. If you take here, we can get the pure form of a higher alkane. So to get the pure form of higher alkane, you have to take a same type of alkyl halides. So if you are taking the same type of alkyl halides, definitely you will be getting here even number of carbon containing symmetrical alkanes. So that's why even number of carbon containing alkanes we can prepare, or symmetrical even number of carbon containing alkanes we can prepare, and we should not take here tertiary alkyl halides. So if you take these three conditions, then we can easily answer the question here. So first of all, if it first option, if you take here methane is a one carbon compound. The methane cannot be prepared by Wurtz reaction because in Wurtz reaction there is a carbon-carbon bond formation. And second option, if you take here, it is a 3 carbon compound, so this cannot be prepared here. And third option, if you take here, it is a 4 carbon alkane here, so this we can prepare. And the fourth option, if you take here, fourth option is also an even number symmetrical. But to prepare this one, we have to take a tertiary alkyl halide. So where tertiary alkyl halides cannot be taken by this. So what will the answer means here? The answer will be, so we can take only here this type of compound, that is here we can prepare only here in butane, that is 4 carbon compound. So this type of questions we will be getting here from named reactions. Now let us take one more question here. So one more question based on the named reaction. Let us take one more question based on the named reaction. So let us take another question here based on the named reactions. So what will be that question means here? So question can be given in this way here. Which one of the following reactions, which one of the following named reactions is sorry, which one of the following reactions show isocyanate group as so isocyanate as a intermediate. So if it is given like that here, then what we have to do is here, suppose options were given in this way. Which one of the following reactions show isocyanate? So what will be this isocyanate means here? NCO, isocyanate intermediate will call here. So that intermediate is produced means in which of the following reactions it will be there means here. If options are given in this way here, first option if it is given as a Hoffman bromamide reaction, and second option if it is given it as here Schmidt reaction, named reactions. These are all the named reactions. If named reactions are given, Hoffman bromamide reaction, Schmidt reaction, and suppose if it is given as Lozenges reaction, and the fourth option if it is given as all of this. The question is given like this here. Then how to predict the answer is isocyanate intermediate. Isocyanate intermediate means the group is NCO here. Isocyanate intermediate. So this isocyanate intermediate generally we'll see in case of Hoffman bromamide reaction, where there is migration of alkyl group resulting in the formation of isocyanate intermediate. So this isocyanate intermediate upon hydrolysis will be giving here the products primary amines which will be preparing in Hoffman bromamide reaction and carbon dioxide. This upon hydrolysis it will be giving here. And this we can also see in Schmid reaction, where it will also be producing here isocyanate intermediate here NCO. Or we can also see in Lawson reaction. In Lawson reaction, where we'll be using here for the preparation of here primary amines. So in that way we can opt here all of this as the option here, because in all of this named reactions we can see isocyanate as a intermediate here. So sometimes the questions can be based on the reaction intermediates. So reaction intermediate, if we identify, then we can write the correct product here based on that reaction. So questions can be given this way here based on that intermediates also here. Okay. So we can take questions like this here. Now let us take one more question.